Hi guys, welcome again to Abstronic Circuit tutorial. Now, let's review my previous circuit video tutorial about the NOT logic gate and the null logic gate. As you can see, the NOT logic gate symbol and the circuit equivalent diagram and the truth table. So when input A injected by logic high, then the output will be logic low. So this time, let inject the input A by logic low. So therefore, when the input A logic low, then the output will be logic high. Take note guys, the input A and the output B always in the opposite. So when the input A is high, then the output B will be logic low. When the input A is logic low, then the output will be logic high. Now let's review about the null logic gate. Then let's combine the NOT logic gate and the null logic gate. So let everyone watching my previous video about the NOT and null logic gate to understand my present video tutorial which is discussed right now. Now let's review about the null logic gate. So when the input A injected by logic high and the input B injected by logic low, then the output will be logic low. And when the input A injected by logic low and the input B logic high, then the output is still logic low. But when the input A and B injected by logic high, then the output will be logic low. When the two input injected by logic low, then the output logic high. Now, let's combine the NOT logic gate and the NOR logic gate. You can see the two combining circuit, the null logic gate and the NOT logic gate. Now let's see how the two combining circuit working together. As you can see, the two switches from the input A and input B will be open. Simply it means the two input will be logic low. So when the two input logic low, the collector emitter of both transistors will be acting like as an open switch. So therefore, the output of the NOR logic gate will be logic high. As you can see, the current flowing from the battery through the resistor and flowing to the input of the NOT gate. So when the input of the NOT logic gate is logic high, then the output always opposite, which is logic low. And you can see the LED is off, simply because the output is logic low. And you can see the current from the battery flowing through the resistor and flowing directly to the collector, since the transistor acting like a closed switch and the current going out from the emitter and back to the ground. So therefore, no current or no output flowing through the LED. Now, let me close the switch from input A. So therefore, input A will be logic high, and the input B remain open, and it will be logic low. Then, the collector emitter of the transistor 1 will be activated, acting like a closed switch. So therefore, the current from the battery flowing through the resistor, entering directly to the collector and going out from the emitter and back to the ground. Since the switch 2 is open, then the transistor 2 is not activated. So therefore, the output of the NOR gate will be logic low, simply because the current from the battery flowing through the resistor, entering to the collector of the transistor 1, then going out from the emitter and back to the ground. So therefore, no current flowing through the input of the NOT gate. So when the input of the NOT gate is logic low, therefore the output will be logic high. Now you can see the LED is glowing. Now, let's reverse the situation. Open the switch 1 to make the input A logic low, and closing the switch 2 to make the input B logic high. Now let's see what happened to the output. Now, the input A will be logic low, and the input B will be logic high. So the collector emitter of the transistor 2 will be activated, acting like a closed switch. So the current flowing from the battery through the resistor and flowing directly to the collector of the transistor 2 and going out from the emitter and back to the ground. So therefore, the output of the null logic gate will be logic low. So when the output of the NOR gate is logic low, then logic low will be injected to the input of the NOT gate. So when the input of the NOT gate is logic low, then the output will be logic high. Simply because the collector emitter of the transistor from NOT gate will be open switch. So therefore, the current just flowing to the LED and no current flowing through the collector and emitter. Now let's try closing the two switches to make both input A and B logic high. So let's see what happened to the output from the NOT gate. Now, let's close the two switches and the two input A and B will be logic high. So therefore, both collector emitter will be activated. So the current from the battery just flowing through the resistor, entering to both collector and going out from the emitter and back to the ground. So no current flowing to the input of the NOT gate. So therefore, the input of the NOT gate will be logic low. So the output will be logic high. Simply because the transistor from NOT gate acting like an open switch. So no current from the battery through the resistor flowing to this transistor. So therefore, all the current just flowing to the output that causing the LED is glowing. Now, you may know how the two combining circuit, the NOR gate and the NOT gate, working together. So just watching guys, my previous video tutorial about the NOR gate and the NOT gate, which is the part 1, and this video tutorial is the part 2. So guys, thank you very much for watching my video tutorial. So don't forget to like and share.